My name is Angelos Tsiaras, and I'm a postdoctoral researcher at UCL. I'm working on exoplanetary atmospheres.
Cool. Thanks very much for speaking to me, Angelos, today. One of the reasons that we're kind of chatting is because you and your team at UCL were involved in a pretty exciting exoplanet discovery over the past few weeks. I was wondering if you could tell us a bit about that and exactly how the discovery came about and why it's so exciting.
So we're talking about planet K218b. It was the first time that we found water on an atmosphere, but on a planet that it has similar temperatures to the Earth. So it's within what we call the habitable zone of the star, where liquid water can survive. Well, of course, water has been found before in exoplanets, a few tens of them, but they were all gas giants. This one is not a gas giant. This planet has a radius 2 times the radius of the Earth and weighs 8 times the mass of the Earth, which puts it in the regime of closer to rocky planets.
So how does the discovery actually come about? How do you and your colleagues actually set about looking for exoplanets?
Well, the planet was observed, well, it was discovered by the Kepler spacecraft in 2015, and soon after it was observed also with the Hubble Space Telescope. Not by our team, but the data were available on the Hubble archive. We used this data to analyze the atmosphere of this planet. So we study the light that is filtered through the planet's atmosphere, the stellar light. We measure the stellar light and the small variations caused by the planet's atmosphere to find out what ingredients are in the atmosphere. So in this case, it was water.
Are you able to use this technique to discover other things that are in the atmosphere?
Unfortunately, with the current instrument, it's very difficult, especially for this kind of planets, is only water. Because water is a very strong molecule, it absorbs a lot and it's hiding all the other molecules. Of course, also, we need a very wider wavelength coverage, so we need to observe different parts of the spectrum to see different molecules.
So, what do you think is the scientific importance of discovering an exoplanet with water in its atmosphere?
These planets were expecting to be there, so we were looking for planets like this within habitable zones and also water. But this is the first one. We were not sure that they were there. We were expecting them. But as usually, the first one is the indication that probably there are more. So we will go after more of them and look for other similar atmospheres with water, and why not within habitable zones?
Hmm. Um, is this ultimately searching for signs of life in planets orbiting other stars? Do you think?
We are still very far away from finding signs of life, but this is, of course, one small step forward. So we are looking now for smaller and smaller planets with atmospheres and water, started from gas giants, and now we are into the super Earth regime, and we will push, of course, towards smaller and smaller. And of course, with different telescopes and different instruments, we will be able to see also other molecules and finding what we call biosignatures. These biosignatures may not be exactly what we expect and what we know here on Earth, but this is what we're looking for, anomalies in the planet's atmospheres.
And if we are looking for rocky planets with water in their atmosphere and other gases and things like that, similar to Earth, um, do you think that we are ultimately looking for a second Earth, like a second place for humans to eventually go to? Do you think that's a realistic possibility?
Well, it's a personal opinion that, again, we're very, very far away from finding something like this. And to characterize a planet as as a second Earth, there are so many requirements that I don't think that we will be able to find and verify all of them. So right now we are pushing towards planets that may have some similarities to the Earth. For example, we start with the temperature. We say, okay, let's call potentially habitable planets the planets that have similar temperatures. Of course, if you talk to biologists, that doesn't mean that there is life, of course. But we're trying to find more indications. A second one in this case is the atmosphere and the water, which has not been found before in a similar planet. Then, of course, we will continue with more and more, like, for example, carbon-based species or oxygen, maybe. But these are very difficult to be found, especially oxygen. So the only habitable planet that we know is the Earth. So unavoidably, we are looking for signs that make a planet look like the Earth. Of course, life can evolve in very different ways, and even here on Earth, we have life in very extreme environments which we would have thought they are inhabitable. So we never know. But at the moment, we're looking for things that make a planet similar to the Earth. This planet is very far from being similar to the Earth, but it's the best candidate that we have right now.
um, when the story broke, it was all over the news, and for like a day or two, it was kind of trending on social media and all this kind of stuff. But one of the things I noticed was that there were quite a few people who were kind of saying that we shouldn't be getting excited about this, and I think there were even a few people saying that this isn't an Earth-like exoplanet. This is more like a Neptune style or like a Neptune mass exoplanet. And I was wondering if you were aware of that kind of conversation going on, and what was your reaction to it at the time?
Well, I can speak with numbers here. So as I said before, the planet has a radius 2 times the radius of the Earth and mass a bit more than 8 times the mass of the Earth. Of course, this doesn't make it an Earth-like planet. It's much bigger than the Earth. But at the same time, it's much smaller and has much higher density than a gaseous planet like Neptune. So given the current models and the current data, it's much closer to a model that is described by either a rocky planet or what we call water world. Super Earths are not, we don't have super Earths in our solar system, so we don't really know exactly how they look like and what is their composition. So it is the first, we need to know more about the atmosphere. And this is the first one that we have discovered an atmosphere. I think that it will trigger many discussions in the future on the nature of similar bodies, and we will see in a bit. But at the moment, I think it's closer to what we would call a rocky planet.
I think one of the things that really interests me about exoplanet research and all the different discoveries that have been made is it's kind of shown us just how rare our own solar system is, really, isn't it? Because there are a lot of anomalies that types of exoplanets that we don't find similar planets to in our own solar system.
Indeed, we have found many different kinds of planets that we don't have in our solar system, like Jupiter-type planets very close to the stars, or super Earths, planets between Earth and Neptune, which actually we know now that they are the most common planets in the galaxy. However, we also have what we call observational biases. So our techniques are more sensitive to some kind of planets and less sensitive to other kinds of planets. So finding a solar system type of system, it's quite difficult with the current detection techniques. Of course, from what we understand right now, planets like the Earth may not be the most common in the galaxy, but they are quite common in terms of size, at least. Now, the conditions on a planet is a completely different issue. So we shouldn't be comparing the term Earth-like in terms of size and mass with an Earth-like planet in terms of conditions. Earth-like conditions are probably very rare.
You're kind of talking about the current state of exoplanetary research in relation to the tools that are currently available to you, but obviously this is going to change, isn't it, over the coming decade or so, with things like the ESA Cheops mission and the James Webb Space Telescope. Are you, as an exoplanet researcher, excited about this kind of new wave of telescopes and detection methods that are coming over the next few years?
We are all excited because we're waiting for new telescopes like James Webb and the Ariel space mission, because especially these missions will try to characterize better exoplanets. So as I mentioned before, we need to look at different parts of the spectrum, and James Webb and Ariel will do this for for James Webb, and for hundreds to up to 1,000 planets for Ariel. So we will look inside the atmospheres of more planets. In terms of detections, of course, we have TESS, which is right now flying and discovering even more potential super Earths in habitable zones around cooler stars. And there is also the Plato mission by ESA later, within the decade of 2020. So I think we will have many more planets, interesting planets to look inside and see more molecules, atmospheric structures, because this is the obvious next step to understand how planets look like and what are the conditions on this planet. Without atmospheres, we don't really know. We know nothing about potential conditions on a planet.
It was interesting there that you were talking about how difficult it is to find planets that are kind of exactly like Earth, like things that we would think of as kind of really similar to Earth. And I was kind of wondering about that in the context of climate change on our own planet, and it kind of makes you realize how precious life is. I was just wondering to get your thoughts, as someone who spends his life studying planets around other stars.
I really like this question, and thank you for giving me the opportunity to talk about this, because what I believe, again, it's my personal opinion, that we are looking for planets similar to the Earth. We would like to find life and, of course, habitable conditions somewhere else, mainly because we want to know how rare our Earth is and how rare life is in the universe. Is life part of the universe in general, or is it only here? If we follow the previous thought, if there is one, there are probably many. But our curiosity drives us, and we need to know. We are looking for that. However, whatever we find out there, it's science fiction, and I think that it will still be science fiction for many, many years, decades, centuries, maybe in the future. So it's a much more efficient to look back and take care of our planet instead of thinking of traveling or transforming other worlds. It will take a lot more energy, time. So it's better if we take care of this planet. And of course, in the end, we were developed in this planet. We are made to live here, nowhere else. Nowhere else.
And finally, just to kind of come back to K218b, are there any follow-up studies to be done?
It's very difficult right now with current instruments. It's very difficult to get something more. So the only thing we can do is to look for other planets like K218b and see if indeed atmospheres with water are common. We are waiting for James Webb and Ariel to see more about this particular planet. Right now, we cannot do that much. Even with very large telescopes from the ground, we may be able to find signs of more molecules, but this is still in the future. James, just to mention, James Webb is expected to fly in 2021, so stay tuned.
Okay, will do. Yeah. Well, thanks very much for speaking to us, Angelos, today, and sharing your amazing discovery and indeed the discovery of the whole team. I just want to say good luck for all your future exoplanet hunting expeditions.
Thanks so much. I hope that we'll have more news to share with you in the near future.